Welcome back to CSC 239, Scientific Computing Applications. We are looking at the item analysis for the first attempt of the Module 3 assessment. All but one student attempted the Module 3 assessment before the deadline, the cutoff, which was the start of class today. Out of 5 possible points, the average score was a 70, let's see, that's a 74, because that's like a 3.7 basically. On a 5-point scale, that's like a 70% out of, let's do the math here real quick. So 3.69 divided by 5. Well, wait a minute. 3.69. Hold on. My number lock key was off. Yeah, it's like a 74, very close to a 74%. So that's actually a very respectable average for a first attempt. The students who logged the first attempt took 27 minutes out of a possible 60 minutes to negotiate the assessment items. Essentially, there were only 1 or 2 questions that, for the way students answered, they either answered completely correctly in the same manner or completely incorrect in the same manner. The Blackboard algorithm scored the 16 questions for the assessment, 9 as medium in difficulty and 7 as easy. None of them were flagged as hard questions. What we'll do is we'll go ahead and review the analysis here and then dive deeper into the items that pose the greatest challenge for students. And then after we finish this, you'll be able to take up the reconciliation promptly. And at that point, we'll go ahead and put out the final versions for retake assessment in this module and the previous module. So the first item that posed the greatest challenge for students in the Module 3 assessment was a multiple choice question that reads, a function is defined, and when executed, a syntax error is displayed, including a pointer that appears at the end of the parentheses symbols. So that's a pretty specific error. And choose the most likely cause of this error. So in your study guide and in other references, this specific error was mentioned. The error is a colon was omitted at the end of the definition statement. So when you define, does everyone understand what we're talking about here?
Yes.
Would anyone like to see an example of what we're talking about? So when you define a function, you have to make sure that there's a colon after that. And if you miss it, it thinks you're trying to call the function. That's what happened there. Okay. All righty. Let's look at the next item. So it was a multiple choice item. And it had to do with these funny symbols. Now, please tell me that some of you, in reviewing your study guide and the other references, saw stuff like this in there. Yes? That information was in the study guide for this module, right?
Yes.
I remembered it from when I did database at Boumediene, so I kind of already knew it.
Oh, okay, very good. Well, it's good that there's overlap then, huh? It means that your effort in that class wasn't wasted. Come in handy. Okay, so the following relational algebra operator is represented by this symbol. So just as we have operators in computer architecture, like and, or, and not, we have relational algebra operators like multiplication, division, and subtraction. And this one, right, it's called the selection or not of given fields in query design. So when you're inside Access and you're performing the query design view like we demonstrated in our last class. Everybody remembers we had a query in design view last time?
Yeah.
Yeah. You're actually using this operator, which is pretty cool. So that's the power of relational algebra. The next question that posed a challenge for students in our Module 3 assessment was a multiple choice question that reads, you notice that a relationship between two tables in Microsoft Access does not reflect a one-to-many relationship. Now that means it doesn't have a line that shows a 1 on one side, and then what is that other symbol that we look at? What's the other symbol that's in the mix?
The infinity sign.
The infinity sign, yes. And on the infinity side, that's the many side. Where it shows the number 1, that's the one side, and then where it shows that sideways letter 8, that's infinity, that's the many side. And it says, however, it's quite certain that a one-to-many relationship exists. So what we have is a table where there's a single record, and then it's tied to a table where there are multiple records that tie back to a unique value in the first one. And we know that it's supposed to be a letter 8. I mean, a sideways letter 8 or an infinity symbol. It is also important to preserve the dependencies between database tables so that a record with related data in another table cannot be accidentally deleted. That's the reference to cascade. Does anyone remember the term cascade?
Yes.
So in here, you can see my screen. So if we enforce the referential integrity and we adjust this join for a one-to-many relationship, we can also check the box that says cascade update and cascade delete related records. And that, if you check the referential integrity and you leave this one unchecked, basically what this means is if you delete one record, it's going to purge the data in other tables, and that's not always desirable, okay? Depending on the circumstances. I mean, now sometimes you don't want strays or orphaned data sets, orphaned data records. So this gives you the chance to exclude the possibility or include the possibility. So if you delete like one record here and it's one to many, it's going to go down the food chain and delete all the related records if cascade delete related records is enabled. But in many cases, depending on the relationship, you don't want that, because if you delete a reference here, then there's no way to tie the data in all these other tables. So it's kind of a dangerous sort of thing. You're trying to trim their hair and you cut their throats instead. That's a bad analogy, but that's basically what's happening here. I hope that additional explanation is helpful. It says you edit the relationship to enable referential integrity. If you turn on and enable referential integrity, it prevents the accidental deletion of data in other tables. But if you check those other boxes, especially that one that says yeah, delete cascade, then it's kind of like a chain reaction, a domino effect. So if you know, if there's a form where a database, let's take this a step further. If you have a database admin, has anyone ever heard of the professional title of database administrator or DB admin? Yes, no, maybe. You know, if you're good with databases, you can work in research and development, right? Hello? Database administrator, how much do database administrators make in, oh yeah, this is a pretty decent. Let's see what 2022 or 2023 database administrator in 2021. Everybody see this? That's the median salary for database administrators in the United States in 2021. That's not too shabby, is it? So knowing about this and understanding this, so there are cases where if you're a DB admin and you want to maintain your data sets, and so it's your responsibility to prune or cut back, kind of like shrubbery, right? Where you have to maintain and you know, work on the integrity of your data sets. There are cases where you want to be able to surgically eliminate certain records from the set. And in that case, you would use these extra features. I know we didn't spend a lot of time talking about that in class, but I just thought I would share that with you. Any questions about that? All right. So the next item that posed a challenge for students was a multiple choice assessment item called one-to-many. For a one-to-many relationship between two tables to work properly, the following is required. And so a couple of students answered other options, but the correct answer is a table structured so that records are uniquely identified. No duplicates. That's where the primary key comes in. So you can expect another assessment item that says, what do you have to do for this to work right? Well, you have to have primary keys. That means it's indexed and there's no duplicates. That's another way of putting this, okay? All right, moving right along. Can someone unmute your microphone and let me know we're still there?
Still there.
Okay. So there was a bit of Python in there, right? And in order for you to execute the Python, you had to be able to change the permissions, but then you also needed, well, you needed to be able to change the permissions, right? And so I think there was something in there about how to change the permissions. And was this the command that you used to change permissions? Well, obviously you don't. That's why it's false. Does anyone know the name of the command we used to change permissions?
I do not.
Anyone? So this changes ownership. So you can change ownership so that you can take a file or a directory and assign it to someone else as the owner or another group as owners. That's what change ownership is about, chown, right? Change mode or chmod, CHMOD, is if this was about, and let's see what the rest of this thing reads. It says, the owner can do everything, all possible permissions. That's 7. So this is the owner permission. That's the key to set the owner permissions. And when it's 7, that means read, write, and execute is turned on. 1, 2, and 4 is turned on. 1, 2, and 4 adds up to 7. If the group is assigned to read and execute, read, write, and execute, that means that write in the middle is turned off. So 4 and 1 makes 5. And then everyone else in the world, all others, they have no permissions. It uses a 0, except that you use ch mode instead. That's all. So moving right along. This question was worth 1/4 point. And I think that based on what I'm seeing here, maybe only one student got it right. Let's see. Only one student got the question wrong. We'll come back to the items where only 1 or 2 students got them wrong. What I want to do is come down here to the multiple answer or ordering questions, because they were worth a lot more. So let's look at the ordering question. It reads, order the steps taken to import CSV data files with headers and Microsoft Access to create a new database table. Now, this is what we had to do for the assignment, right? Everybody remember that? So if you did the solution, then you'd know the first step is to select new data source, then from file, then select delimited. Basically, you're walking through the steps that we did to import. Enable use of first row for field names, then change the indexed option to yes, no duplicates, then change primary key option to choose my own, select the key field, and then 5, provide a suitable name for the DB table. Now, what I'd like to advocate to everyone is when you have a question like this that's complex and it has to do with the steps in the solution, if this is an open book assessment and students had 60 minutes to take the test, and the average student only used 27 minutes. One thing you could do is you could open up Access, right? And then you could go to the external data option here. Wait a minute. Hold on. Oh, yeah, I got to cancel this dialog box. That's why it's locking me out. I can go to the external data menu. I can go to new data source, and I can walk through the steps of the import. And then in that way, I can just follow along with the question. I can do that on the side and just use Alt-Tab to switch between the test and the Access environment. Did anyone think about doing that in the middle of the assessment? Was anyone tempted to do that?
I didn't do it.
Yeah.
I mean, does it help if I tell you it's okay to do that because it's open book? Now, once you get to the exams, or if we're doing a cumulative exam, you're not gonna have time to do that, but yeah, okay, fair enough. So here's a question that posed a challenge for students. It was a multiple answer question, and half of the students did not receive full credit. Question reads, you want to prevent garbage in, garbage out, as data elements are collected for qualitative analysis. So as soon as we talk about, we're not talking about numbers. If it's just raw numbers, then data input can often be cleaned up or controlled by using sensors or input devices, right? So you can automate the input of data if it's quantitative data, if it's numerical data. You can use a Raspberry Pi with a sensor and you can put in temperature readings all day long, right? And nobody's screwing those up. But when you say qualitative analysis, you're talking about relationships, how the digital information beyond numbers is related. So which of the options listed below will help you achieve this simple but essential purpose? Use forms to control how data is entered and incorporate the use of lookup tables for consistency. Okay, that's something that we reviewed in class, I think, right? So everyone got this multiple choice correct, I believe. That's why it's showing it cannot calculate. Let's just make sure that. Yeah. So that's the correct answer. Nobody chose the other answers. It's good. That's why it was, everybody answered consistently. Here is one more multiple answer item. And here's a multiple choice where I don't think everybody did so well. Yeah, these last three. Let's look at these last three. So the question reads, a researcher must collect data for measurements of turbidity. So when we say water clarity, we're talking about how clear is the water, right? It's collected from a sensor using real numbers or floating point numbers. So when we say real numbers or floating point numbers, what kind of numbers are we talking about? Anyone?
Like 1, 2.
Well, those would be
So-
those would be whole numbers, right? So if you say
Mhm.
1 and 2 and 16, and there's no decimal, then those would be integers, right? Real numbers have decimal places. There's a decimal point. So I'm actually glad that you spoke up, because that's one thing that we want to call out here, right? The fact that we're making a point about that it's real and they're a floating point. Floating point means decimal point, right? So it says select any item below that are part of recommended practices for collecting data. And it says, one of the answer choices reads, an appropriate name for the input variable is real, meaning you could say float, or you could say real, but using the term real means, okay, that's the data type for turbidity levels. So that's a good choice. What's wrong with this choice right here? Because a student answered this. What's the problem with just using T for that variable?
It could mean anything.
Yeah, I mean, what other values could T represent, right?
Time.
Temperature? Can you think of anything else T represents?
Time.
Time. Yeah, time, exactly. Time, temperature, anything else? We have any musicians in the audience?
Tempo.
Tempo. It's time related, yeah, but has to do with beats per minute. Anything else besides T?
Anything that starts with T?
Yeah. Type, right? We already said temperature. Tooth, like which tooth? Could be a dental application. True story. When I was working in the field as a certified systems engineer with Microsoft, I went to some dental practices and they had someone that came to their office that set up office software for the dental practice. It was a database. And guess how much money they made off of each dental practice in a 3-state area? Guess how much each dentist paid them to run that database? Go ahead, guess. A 100 customers. In 3 states. They paid $25,000 a year. This was 3 or 4 developers that ran the database. And their combined income for the small shop was $2.5 million each year. Pretty cool, huh? I mean, if you get the database stuff right, it really pays off. So I know I'm kind of taking a side trip here and there, but I just wanted to share some value about some of this stuff in our course. All right. So this is the other item that students selected. It said, given the sensor output, the variable input values should use the integer data type. What did we just say about the integer data type? What kind of numbers are integers?
You were saying like 1 and 2.
Yeah, whole numbers. Whole numbers without decimal points. There's no point. It's when you do calculations with it, the decimal place doesn't float. It doesn't like if you take. So I guess the idea of floating point is that when you have a number with a decimal point and then it's in a series of calculations, what comes out of there, the decimal place, it's in a different location on the other side of the calculation. So in a sense, the decimal point floats, right? Now, I'm not a professional mathematician, and could be that the mathematics professors scold me and saying I'm oversimplifying that explanation, but yeah. Real numbers, you know, you have a partial value in the real world. You rarely have whole numbers to deal with, right? Just like you rarely have whole dollars. Does anyone shop in a store where you only use whole dollars to buy what you're doing and there's no change involved? Kind of unreal in a sense, or not real. Anyway, multiple choice. 34 was the rating here. So this was a multiple choice question, but there was a diagram here. And it says, please reference image B below. Which database table has a unique bidder ID? The key word here is unique, meaning the bidder ID is only used once in that table for each bidder. And which table can have multiple entries for a given bidder? So we're identifying the table that has only one and the table where there's many. Okay, that's the bidder ID, right? So, and by the way, AI means auto integer, right? So which tables are the ones here for bidder ID? Well, it's pretty simple. There's no bidder ID in the auctions, right? Everybody can see that, yeah?
Yes.
So we know intuitively that in order to have an auction, you have to have bidders, right? All right, let's think about this. And this is where the database wrinkle in your brain, I'm kind of hoping kicks in. So I'm going to take time I've noticed that there's about a half a dozen concepts, just 5 or 6 concepts about databases. And if you get those concepts about a database, you can make a ton of money working with databases. You can be very efficient. It can be one of the strongest things you do. And that was true for me. And so this is one of the things that I learned a long time ago. Here's the auctions table. And I know intuitively that there have to be bidders in an auction. There have to be. Otherwise, there's no auction. What's an auction without bidders? And yet, if you want really efficient, high performance databases, when you normalize the data, you realize, hey, it's the bids table that joins the two data sets between bidders and auctions together. So what we're saying here is that if you take the time to suss out or diagram, and this is one thing that most people don't take the time to do. How many of you have had physics classes or chemistry classes? Anyone? Or
For me, it was back in school,
or how about geometry classes? Anybody had geometry?
back in high school.
Yeah. Did it help to draw things in
I'm a
geometry?
visionary learner, so yeah, I always prefer to see it.
Yeah. Yeah, I think what happens is that people have quick notes, right? And they have computer screens now, but there's something about taking a writing implement in your hand and just starting your own process here, right? So the idea here is to take the data sets and break them down so that they're in their smallest possible combination for each set. All the related information for bidders at its bare minimum that you need, the minimum detail you need, the minimum detail you need for auctions, the minimum detail you need for bids. If you look at this, I have ID numbers for 3 of the fields. And then I have a single value here for the bid. Does everybody see that? That's all I have. Now, can I share something else with you that should be kind of profound? Shamira, you've taken some cyber courses, right?
Yes.
Okay. So you know the databases, flat databases in particular, where they lump everything together like a giant spreadsheet in Excel? Hackers love that because all the information that matters is in a single file. It's like a gold mine, right? It's highly condensed, very valuable information. If you get a hold of a database in a bank or a database in a hospital, you own the place, right? Because all the information you need to own that place is in that database. And that's if a database is poorly designed. But take a look at this table right here. And this is what I want to ask Shamira. So we're going to take a little time to kind of suss this out today. If I take the time to diagram this properly, where it's very efficient, what else do I gain from that? Let's say that you have a hacker that gets in there and they get a hold of the table, the data table for bids. Now look at what's stored in the table for bids. If they hack the database for bids, the table for bids, can they tell anything specific from this one table? I mean, do they know who the richest bidder was?
No.
Or at least the bidder that has the most commitment, right? I mean, the highest bidder may not be the richest bidder at the auction, correct?
Correct.
Yeah. And can they tell where the really juicy auctions are? Oh, here's the auction for Buckingham Palace. Oh, here's the auction for the tools that were part of the estate of Tom's Motorcycle Clinic. And it's a shed, and there's rusty old tools. and Tom had a club, and it's Tom's motorcycle repair tool shed, right? Can you tell from looking at the rest of this stuff which auction has the most cheddar, has the most gold, is worth hacking because there's the greatest value? If you hack this, if you look at the volume of bids, the location, the date, well, you might be able to tell something from the location. But that doesn't mean that you know who the bidders were at it, or the value of the bids, right? Or for that matter, the items. Would it be easy to add a data set for items that were bid and tie it to the bid? What do you think? I mean, look at this picture. Is this a complete database for an auction database? We have the auctions, we have the bids, we have the bidders. What else is missing?
The items.
The auction items, right? Right. The auction items. And then couldn't we have like the bidder payment table, right? Because bidders are going to bid, but then how do they pay for it, right? You could have another table for payment instruments. It gets back to the customer service kind of thing. What I'm trying to suggest here is, with the right structure, you can create highly efficient applications, and it's very easy to extend or expand them if you use this modular approach and if you normalize the data, meaning reduce it to its lowest, so the smallest related set, right? And the added value is, it's a lot harder for hackers to understand what the hell's going on. They get one of these tables and they're like, okay, yeah, I know this has to do with bidders, but I don't know anything else about them. I don't know what kind of bids they made. I don't know what auctions, where they were. I don't know if they were bidders at Buckingham Palace or if they were bidders at Tom's Motorcycle Shack. Okay. I hope that helps. Well, it says which database table has unique bidder IDs for each bidder. Well, this one obviously doesn't. So any answer with T auctions is out. So that's why this, right? This answer is out because auctions has nothing to do with it. This is out of there. The only one that's in there that works is T bidders has only one record per bidder, and bids can have multiple records for a given bidder. So that's the answer. Any questions? Last item. And then what we'll do is, if you want to, you can get started on the reconciliation right away and get it done before the day is out. So right here, the multiple answer question is, and it has to do with this image. With regard to qualitative analysis of experimental data and the use of relational algebra, the following database has been configured using Microsoft Access. What significant considerations or conclusions can you identify given the details shown in image A below? Select all that apply. So for this given scenario, we want you to pick the answers that apply. Well, the turtle species ID shown in the sightings table is a foreign key. So the turtle species ID shown in the sightings table is a foreign key. Turtle species in the sightings table, if it were a primary key, it would be on this side. If it were a foreign key, it would be where the infinity is. So that's something to remember. If you want to know how to pinpoint the foreign key, look for the field closest to the infinity symbol, okay? Duplicates of the turtle species ID are allowed in the sightings table. So what are we saying? we can have more than one of the same species when we're discovering those turtles in the field. When those turtles are sighted, you're out in the wild and you're in the water and you see them, those are sightings, then yeah, you can have more than one of those in the sightings table. But you can't have more than one species ID in the species lookup table, right? The turtle species ID shown in the species lookup table is a primary key. And because it's a primary key, each entry is unique. You cannot have duplicates. So a primary key is always a single record that's unique. And the foreign key are multiple connections to that single record. So duplicates are okay over here, duplicates are not okay over there. Now, student answered, both turtle species ID fields exhibit a one-to-one relationship, values and data types match. If that were true, we'd have a line, but no one-to-many. So that's why that answer is false. Any questions before we? I mean, 74% is a good score for a first attempt as a class average. I don't know if you're proud of yourselves, but I think that's really good considering the complexity of the material. I would be pretty happy with that. What you can do now is go ahead and submit the reconciliation. You see that it's due this Saturday. I'd like you to reconcile promptly if you can, just while the trail is fresh. And then over the weekend, I'm going to post the final versions for the assessments in modules 2 and 3. So early next week, you'll be able to retake the module assessments for module 2 and 3. And then we'll begin on Tuesday in module 4, okay? Does anyone have any questions before we clear today?
No questions for me.
All right.